In this video, I want to introduce you to velocity graphs and how you develop velocity graphs from position graphs. At the end, we will also see how these graphs are connected to the acceleration. In this graph, we see the position of a student while the student is moving forward. This is a position versus time graph, which is also just called position graphs. From this graph, we already get a bunch of information about the motion. At first, we know when the student is where through the data points in the graph, but we also get an idea about the student's speed. When we look at the last section, the student walks roughly for 2 minutes from t equals 7 minutes to t equals 9 minutes. In that same time interval, the student moves from the position x equals 300 meter to x equals 500 meter. So in that time interval, the student moves 200 meter forward. When we compare that to the motion in the middle section, we see that the student walks only 50 meter in 2 minutes. That already gives us information about the speed. As you remember from high school math, the rise over run in a graph gives us the slope. When we apply that in position graphs, the slope is equal to delta x over delta t. But in a previous chapter, we learned that the velocity is defined by v equal delta x over delta t. This is why the slope in position graphs gives us the velocity. Because the velocity is defined as v equal delta x over delta t, the velocity is the slope in position graphs because it is equal to the rise over run. Let's calculate the velocity of the student in the last section. We mark the rise over run and plug in the values to calculate the slope. When we plug in the values including the units, we obtain for the velocity 100 meter per minute. Let's look at a position graph of a free fall. This graph has a constantly increasing slope. Also in this situation, the slope gives us the velocity values, only that at every instant we get a different value for the slope. The respective velocity graphs is shown beneath. Because of the definition of the acceleration equal delta v over delta t, the slope in the velocity graph gives us the acceleration value. In the case of a free fall, the velocity graph has a constant slope, which means that the acceleration is a constant value.